Lesson 11.1, Task 5. Model with inverse variation. The amount of gasoline used on a trip varies inversely with the fuel efficiency of the vehicle. Samuel and Parvati both rent more fuel-efficient vehicles for a 400-mile road trip instead of driving their own vehicles. All right, so let's call Samuel Sam and Parvati Par. All right, so Sam has a personal vehicle that he gets 14 miles per gallon. Par has a vehicle that gets 36 miles per gallon. If Sam rents a vehicle, he's going to get 21 miles per gallon, and Par will get 15 miles per gallon with a hybrid rental. All right, so it says write and graph a function to model the amount of gas Y in gallons used during the trip while driving a vehicle with fuel efficiency X in miles per gallon. Which rental will save more gas? All right, so we want to look at this. If Sam goes from 14 miles per gallon to 21 miles per gallon, and Par goes from 36 miles per gallon to 50 miles per gallon, which one is going to save more money or more gas? More gas equals more money. All right, so it says write a function. So the amount of gas Y used varies inversely with the fuel efficiency X. So the model is Y equals 400 over X. All right, so we know that the miles driven times the gallons of gas is going to equal how many miles that your trip is. So your constant of variation, your A, is the 400. If you remember, we're taking a 400-mile road trip, okay? But also we know that the amount of gas in gallons times the miles per gallon equals 400 miles, okay? So since we know that X times Y equals 400, we can divide both sides by X to get Y equals 400 over X. So that's why the constant of variation is 400. All right, it says graph the function. If you graph the function, if you expand your window to be the same as this, you should see this graph, okay? So it says, what are the graph's isotopes and what do they mean in this situation? All right, so as this approaches, as X approaches infinity, this is going to approach 0. So what does it mean? It means that the this is fuel efficiency. So as the fuel efficiency gets better, then it's going to take less gallons of gas, okay? All right, the other isotope would be your vertical axis, or Y equals 0. And that would be the less fuel efficient. If you come this direction, you can see it's less fuel efficient. So like say this point, it's less fuel efficient, so it's going to use more gallons of gas. So that's what the two isotopes would mean in this situation. All right, so it says answer the question. Sam's personal vehicle would use 400 divided by 14 or 28.6 gallons of gas, while his rental will use 400 divided 21 miles per gallon or 19 gallons of gas. And these numbers here, 14 and 21, that's what they gave us in the picture here. So his personal vehicle was 14 miles per gallon. The rental was 21 miles per gallon. So they're just putting those numbers into the equation to figure out how many gallons of gas it was going to take. So his personal vehicle, 28.6, rental, 19 gallons. All right, Par has a personal vehicle that would use 11.1 gallons of gas. Her rental vehicle would take 8 gallons of gas. So Sam's gas savings would be 9.6 gallons. And then whatever that is times the cost per gallon would be how much money he saved. But he's saving 9.6 gallons of gas. And Par is going to save 3.1 gallons of gas. Therefore, Sam's rental will save more gas over the 400-mile trip. And if you look at that on the graph here, you can 14 and 21, this looks like these are Sam's points here. So 14 is his personal vehicle, and then 28.6 was the gallons of gas, and then this was his rental. And then you can see that PAR's points are down here. All right, so it says compare the average rate of change between the red points and between the green points. All right, so average rate of change we know is y minus y. So if we do 19 minus 28.6 over 21 minus 14, all right, so we can do 19 minus 28.6, and that's going to be negative 9.6, and then, let's see, negative 9.6, and then 21 minus 14 is just 7, so let's divide this number here by 7. So Sam's average rate of change would be about negative 1.37. So that means with his rental vehicle, on average, for each mile, he's going to save about 1.37 gallons of gas. All right, so let's see for PAR what that would be. So for PAR, we have 11.1 minus 8, that's our y minus y, over x minus x, 36 minus 50. So let's do 11.1 minus 8, 3.1, and then 36 minus 50 should be 14. So we've got 3.1 over negative 14. And if we divide those two numbers, we're going to get well, let me try that again. So 3.1 divided by negative. Sometimes these calculators don't like the minus sign instead of the negative sign and vice versa. So PAR is going to be negative 0.22, average rate of change. So negative 0.22. So that means she's going to save, on average, 0.22 gallons of gas for every mile, as he saves 1.37 for every mile. So there's another way to show that Sam is getting a better deal if he rents a vehicle, or he's going to save more gas. All right, looks like that is all for task 5. If you have any questions, please let me know.